To give you a little background, I initially trained as a classical physiologist in exercise physiology. And then I did some stuff in spinal injury on how your autonomic system recovers after that. And then I moved to Walt Randall, and that's when I got into the cardiac stuff. And that's where, together with him, Walt Randall and Drew Armour, we created the field of neurocardiology. Right, well, when we first started off here, you'd work with a single electrode going into a single area. You'd record from single neurons, and you try to extrapolate to the whole animal from a few different signals that you were seeing. Where this whole field has evolved now is that we can now go in with the new types of interfaces we're developing, and we can record from multiple areas, record lots of neurons, high density recordings from the heart. We can really understand the interface between the neurons and the heart. What they allow us to do is we can actually put those on the heart. They are extremely flexible, so they move with the heart, and we can actually get very high density recordings from various parts of the heart. And we can also stimulate from those areas. So we have the ability to do really careful analysis, not only of the electrical activity, but also mechanical activity. We are developing some collaborations with other groups where they're actually doing track tracing from those electrodes, and we can get beat by beat, millisecond by millisecond electromechanical coupling of the heart. We can now look at things in much greater resolution over time and space. Along those lines, we're also working with other people to develop new technologies for determining neurochemical transmitter basis on a dynamic basis. So you don't have to wait 4 days to go to the lab. You can just essentially from the electrode, you can get that signal immediately. So we're really improving diagnostics. We're improving the ability to do targeted interventions, and it really does have a huge opportunity for the patient population. Basically, the catheters, when I first saw the cath lab, when I first came here, I was amazed by how low density the recordings were. Most of the technology is 15 or 20 years old. You go in with a single catheter, you steer it around, and from those few points, you essentially generate a map of cardiac electrical activity, which takes hours to do. So with that was my inspiration to say, well, can we develop arrays that essentially have much higher density activity where you can maintain that contact quite effectively. And that's why we, with NeuroNexus's assistance, developed these arrays, which can be put on the heart. They are essentially held on there by fluid forces. They can stay on there throughout the procedure, and then you can easily remove them with no damage at all to the underlying tissue.